right, we are back from Mr. Jeffers' Algebra 2. We are up to like 55 subscribers now. We may have to do a 60 subscriber session, which if 100 people subscribe to this is going to crack me up. Okay, so again, thank all the subscribers. Hit the like, hit the bell, hit yourself if you need to. Okay, so all this stuff, I put this up here just because I wanted to. It seemed like a really good idea at the time, and then somebody tried to read it. They're like, "What's log biggie?" Because it's like log sub b base b of y. This is really how it goes. Okay, so if we're taking these log statements and we're rewriting them in exponential form, this is how easy it is. We take this little number right here, this itty bitty 2, and now it's a big 2. All right. And we say 2 to this power, so 2 to the 4th, is whatever this is, 16. And that's all we have to do. You figured that out 10 minutes ago? Well, it's probably because you read the directions. Yeah, a lot of people don't do that. So, all right. Mhm. It's not 14 because you didn't write it correctly. Shh. Okay, let's look at B. What would this big little 4 change to? The big 4. And its exponent is now 0. And anything to the 0 power is 1. Yeah. Okay. Now, on C. Yes. Good deal, Pickle. All right. So this log base 12 of 12 equals 1, that's actually how it's read, not log 12 equals 1. I know some people will do that. This is also the same people that says x squared is x2. It drives me crazy. This is 12 to the first power is 12. Okay. Now, when we got to some of our negative exponents and stuff, this is where people got confused because people may have forgotten it. All right, this is 1/4 to the negative first power, and it becomes 4. Now, remember, to take anything to a negative power, you actually do the reciprocal of it. Okay, so instead of it being 1/4, it now changes as 4/1. Okay, and I had somebody like they could not do the whole rest of the notes because they were stuck on this one like the entire time. Yeah, like I was like all the way down at the bottom of the page. They're like, can we go back to D? And I was like, I'll talk to you separately. Okay. Um, and what's funny, those rules of exponents and stuff used to be with Algebra 1. Now they're not. Now they're in 8th grade math. So some people may or may not have gotten them. All right. Now, example 2. Now we're going the opposite way. Okay. So we have to have a log. So we write log. All right. We're going to take this 5 and write it itty bitty down here. So now it's log base 5. Okay. This 25 now goes right here beside it, equals 2. Okay. And it's just a formatting thing. You can't do it with that right now because your calculator will automatically do log base 10 instead of log base 5. Tomorrow we're going to learn about the chains of base. No trouble. Okay. Thank you. All right. This one will be log 10 0.1 negative 0. Now, you also could have written this as log 10 to the 1/10. A lot of people may understood that a lot better. Okay. Again, not wanting you to go super deep into understanding all this kind of stuff and needing you to understand the pattern. Okay, good luck. Okay. All right. On C, we have log base 8, big 4 here, and then 2/3. Okay. Now, the reason why the 2/3 power, remember, if we have 8 to the 2/3, this is the same thing as saying the cube root of 8 squared. Well, 8 squared is 64. Cube root of 64 is 4. Okay. And this one would be log 6 of 1 over 216 equals negative 3. Okay. So what's funny is I've had students that says, is that what all this is, this log stuff? Because like they taken star math, and the higher, the better you do, the higher up it goes. And uh, I've had some students before, they've taken the ACT before they've actually had algebra 2, and they're like, what is all these log problems? What does that mean? I had that when I was a kid. Well, I'm always a kid. When I was in high school, wait, I'm still in high school. Long ago, I had a log problem, and I was like, log is something, to me, a log was something you put on a fire. Okay. And if it was a cedar log, you use it as a corner post for a fence because cedar doesn't rot. Okay. So that's, that's, huh? This is true. It's kind of very invasive. But I didn't understand. And up until like 5 or 6 years ago, I didn't know where a lot of this was used. And a lot of this, because these have a lot of these different curves, and you have to think about it. If you're shooting a signal from somewhere here, it actually has to curve to hit a satellite, and then it also has to curve to come back because of the curvature of the earth, because of the orbit and stuff. That's where a lot of this stuff comes into play. Okay. And maybe I can get that guy to make a video about it. That would help. All right. Yeah, it would make a lot more sense coming from Sergeant Torres as it was me. Now, excuse me. So this right here, evaluate each logarithm. These are super hard. You just hang out. They're super hard. So you could rewrite it like this. Okay. So basically, this is now why we're asking what power of 4 gives us 64. That's where it's like 4 to the x power equals 64. Well, 4 times 4 is 16. What's 16 times 4? Is 64. So this would be 3. Yeah, 16 times 4 is not 4. Not in some weird mathematical vacuum or something, but you're just actually writing that power down. Okay? Yeah, it really is. Like uh the way I've seen these worked out is like, say this is 4 to the x, and this would be 4 to the third, so x equals 3. Y'all aren't going to think like this. Y'all are going to think, I'm going to start typing in 4 to some power to find out what it is to 64. So why would I need to show y'all this? I mean, that's what I would have done. To me, writing it down, doing all that is too much. I would rather type it in the calculator. Okay. Oh, and by the way, there weren't very many good examples on the rest of them, so that's why we only have one example on example 3. All right. Now, this is actually where you get to use um, this. Now, this is what's weird. When it's just like this is called a common log. It's just your regular run-of-the-mill average day log. Maybe like the logs on that trailer in Final Destination. You never know. And then then you have natural logs, and they apply about this kind of the same thing. Now, this is calculator work. So in your calculator, you have a log button. It's can I find it? It's right here. So you're going to type log and then 8. And you don't have to close the parenthesis. Okay. And you're going to get, let's see, I can't do this at the same time. 0.0930. We're going to take it out 4 because it says to round to the nearest 3 decimals. All right, because this fourth one right here is not 5 or higher, and believe it or not, that's what I I don't like rounding stuff with students because I spend more time teaching them how to round than I do the actual lesson. Yeah, rounding has been like I mean, it's yeah, this is yeah. We actually just did this on the calculator and it gave us our answer. Yeah, this is calculator work. Now, right below log, we have our natural log. So our ln, which I don't know why it's ln and it's called natural log. Okay, it's just I don't know. And this gives us negative 1.2039. All right, this fourth one, this is bigger than 5. 204. Yes, I've really had to teach people how to round. Okay, now, believe it or not, this is where we're going to stop for the lesson. Kind of short and sweet, to the point. Um, if you're not in my class, you don't have to worry about what's on the back of this handout. But before you do, thank you for all my subscribers. Don't forget to hit subscribe if you haven't. Hit the bell, hit the like. Good stuff, good things. Roll Tide.